What is going on, guys? I hope you are well. So turns out I have a bit of an issue. Those are air compressors, and the problem I have with these is that they only go up to 8 bar. And I've always wanted a compressor that could go up to something stupid like 40 or even 50 bar. And to achieve this, I'm going to be using one of these. This is a compressor from a fridge. This is what they use in fridges to pressurize the coolant. And these guys can go all the way up to 50 bar, no problem. So this is what I'm going to use to actually, create pressure. Now, to store the pressure, or to store the compressed air, I'm going to be using one of these. This is a CO2 tank. I believe this is 2 liters. So I bought one of these for my MIG welder. And the nice thing with these is that basically they are rated for, 60 bar or more, since the pressure vapor of CO2 at ambient temperature is around 60 bar. So this should be able to withstand the high pressure, no problem at all. So it's extremely important that I use a tank rated for 60 bar, because for instance, if I used this tank and, just slapped the compressor on top of that, if I just let the compressor run, that thing would definitely explode, and so we wouldn't want that. I'll be using this flexible copper tubing to connect the compressor to the tank. This stuff is really nice because, like I said, it's flexible and really easy to work with. And of course, they can withstand super high pressure. And I'll also be using this nice chunky piece of steel to create basically the necessary plumbing to hook up all the valves to the compressor. And speaking of valves, I'll be using these really nice ball valves, and these should be able to withstand 60 bar, no problem at all. So this tube here is the intake, and then this is the outtake. So the idea would be to have this this block here positioned like that. This tube would feed into it, and then I'm going to have to drill a few holes so that I can have my ball valve sort of positioned. I'll have maybe one here, and then one on the other side. And then I'll be using this nice pressure gauge. This goes up to 60 bar, and I'll have this positioned on top like that. Okay, so let's get drilling. Okay, so this is what I ended up with. I thought about putting one valve here and then the other one here, but then I changed my mind and I thought I'd just have them vertically like I had planned originally. So this is the air intake. This is what I will hook up the compressor to, and I'll probably just seal it with epoxy. This is where the pressure gauge will be positioned, so something like that. And then I'll simply have one valve here, the other one there, and then another one right there. So off camera I drilled a small hole right there, so this will be the air intake. Down here, using the grinder disc, I removed some of the paint because I'm planning on welding this somehow to the compressor. So this will probably be seated like this. Then I'll have a valve running from this tube here all the way up to the intake of the tank. So let's get making the steel plates that will be used to hook up the air tank to the compressor. So here's some good news. This hole I drilled, way too big. So that's a bit of a problem. So what I'm probably going to do is I'm going to weld a nut sort of in this hole to, seal it up. And then I'll just drill a smaller hole next to it to replace it. Yeah, that should do the trick. And to connect this tube to the valve, I'm going to be using these quick disconnects. And the reason why I'm not just brazing it directly to the valve is because I want to be able to take it apart, for maintenance or whatever. So the next step is going to be to silver braze this tube to the block, and then silver braze the copper tube to the tank. Of course, I'll be using rods that contain at least 40% of silver. This is important because when you want to braze copper to steel, you need to use rods that contain at least 40% of silver. And in this case, I'll be using these ones right here. And this is what that looks like. Now, it's definitely not the prettiest thing in the world, but it will certainly hold. So now, for every connection, I'm going to add a few layers of Teflon tape, and this, of course, will prevent any leaks. Alright, and so for the plumbing, I believe we are done. Alright, moment of truth. So it's running, let's close this valve here. And now, basically, the air is it's blocked here, so it'll be forced to run into the tank. So let's see if that pressure gauge is going up. So you can see it's taking a really long time. That's simply because these compressors have very low flow rate. So yeah, let's just see how high it goes, and hopefully it doesn't blow up. And I'm not gonna lie, I'm a little bit scared. Please don't blow up, please don't blow up. Uh-oh. So, yeah, so there's definitely a leak right there. Yeah, you can see that. Okay, and you know what, there's one here too. And probably one here as well. One up there, yeah, so it's leaking, it's leaking everywhere. That's probably because I don't have enough Teflon tape, or maybe it's just not the right kind, so I'll try and see what I can do. So if I open this up, should make quite the whoosh. Okay, so what I did is I just went ham on the Teflon, and I just tightened the crap out of it, and that seemed to have worked. I'm not having any leaks. Right now we're at 40 bar or 600 psi. So yeah, now it's getting a little. Now it's getting a bit scary, but yeah, like I said, it should definitely hold up just fine. So what I'm going to do now is I'm basically just going to let this thing run until it stalls, until it can't compress any higher. This is just so I can make sure it's physically not able to, well, go over the maximum rating of the components, because if it did, then that would be pretty bad. Even though this thing looks like a time bomb, I wouldn't want it to actually be a time bomb. Okay, now we're at 50 bar. Compressor's making a different sound now. I don't know if you can hear that. Compressor's not too happy, I don't think. You know, these things, they're not exactly designed to go up to these pressures, but they just happen to be able to. And it's quite interesting how this tube is getting really hot. That's because, you know, PV equals nRT, so when pressure goes up, temperature goes up. And there it goes. So that was probably an overheating protection. I don't think that was an overpressure protection. But either way, we're up to, yeah, almost 60 bar. Uh-oh, it's smoking. Okay, so that was not a protection. That was just the motor that just fried. Well, that's good news. Okay. All right, let's empty that. Yeah, that bloody stinks. So I'm just going to let this compressor cool down for a bit. Hopefully I didn't damage anything. So yeah, it would seem these compressors definitely can go up to high pressures, but unfortunately they can't run for too long. This is because, you know, of course, when the pressure goes up, the load increases, which means that the motor will pull, too much current. It'll heat up, and as we saw, it will fry the windings. So I got one of these. This is what's called a PCP air compressor. These are mainly used for like paintballing and stuff. And these can go up to 300 bar. So let's take a look at this. Cost me around 250 euros. And here it is. So this is basically it. And the nice thing with these is that they will run on, mains, but they will also run on 12 volts. So you can run this off a car battery. So this is the outtake, and the compressor comes with this really nice air filter. This just, kind of cleans up all the oil and lubrication that's used to help the motor run nice and smooth. So this plugs into here like this. Very nice. Also, I made sure I got a model that has an automatic pressure gauge, and this can be set to whatever pressure you want, and at that pressure it will switch off the pump. For fun, I took apart the compressor, and you can see that it's actually very straightforward. This would be the main compressor unit, so you have a 12-volt motor, a gearbox, and basically this would be the piston that moves back and forth. This is simply a 12-volt power supply to power up the motor, and yeah, that's pretty much it. And you can see that in action right there, so quite straightforward. And this fan is used to cool down this whole thing because it gets pretty hot. So this compressor actually works in a very similar way to your standard, 8-bar high flow rate compressors. The difference with this is that, well, here you have a gearbox, which means that the output torque here is tremendous. And of course, it's able to push this piston back and forth with a lot of force. The piston inside of here, I'm guessing, is actually very small. Like, the section would be very small. This means that you have very low flow rate, but very high pressures. And that's essentially the trade-off. For a given input power, you either have high flow rate or high pressure. You never get both at the same time. That doesn't really make sense. Okay, so I just got rid of the fridge compressor, and now we're going to be replacing it with this guy. So now it's just a matter of figuring out how to connect this quick release connector to this. Luckily, the compressor came with this little, connector, like the male connector. So what we're going to do is we're going to braze on a piece of copper onto this and simply braze it onto the block right here. And off she goes. So, got the compressor hooked up here, and as you can see, it's climbing up quite nicely. And we're done. Just turn that off. Look at that, 60 bar. Like, there's the tiniest leak right here. I think this is, it's just coming from the pressure gauge. I'll just tighten that up a little bit. And there it is, a nice 2-litre air tank capable of holding 60 bar. So I set the maximum pressure to around 50 or 60 bar. However, this is definitely not a safe way to limit the pressure because, the electronics inside here could fail. The pressure will just keep going up. So what I definitely need to do is to add in a safety pressure release valve. So on this compressor, this would be the pressure release valve. So this means that even if, the electronics in here fail for whatever reason and the compressor keeps going after 8 bar, which is again the maximum rated pressure for these tanks here, this thing will pretty much just open up and release air, which will instantly decrease the pressure. So yeah, pressure safety valves are extremely important, and in most countries they are, mandatory. It would be illegal for a compressor not to have one. So I went and ordered one rated for 60 bar, but I won't be receiving it in time for the video, so I'll be adding that later on. Also, something else I realized is that, although these bottles are rated for 60 bar in normal circumstances, after drilling a bunch of holes and, welding and brazing stuff to it, I'm pretty sure that maximum pressure rating goes out the window. So I'm definitely going to be keeping a close eye on this. I'm definitely never going to leave it under pressure unattended. So there you have it. I hope you found this video interesting. So obviously this is very unscripted and improvised. So yeah, if you like this style of video, let me know in the comments and I might make more. Now, of course, this definitely wasn't a tutorial. This was just, me kind of messing around with high pressure and experimenting with a bunch of things. Yeah, I would definitely not recommend you try this yourself unless you have a lot of experience with high pressure and you're not afraid of having a piece of metal fly in your face and kill you. And there you have it. So I'll definitely be making a separate video in which I will be putting this thing to good use.
Parachute. Ah si.
So, if you don't want to miss that, subscribe, and if you have any questions, leave them in the comment section below. I will try to answer them, and I'll see you next time.